Hello, my dear students. Assalamu alaikum. Today we discuss about gravitational field intensity, and gravitational potential. This is the lecture 5 of gravity and gravitation. Now, at first we discuss about what is gravitational field. If an object is placed at a point, this is the object is placed at the point A. Now, what is gravitational field? The space around an object, in which its gravitational attraction is felt, and that is if any other body is kept inside this region, the gravitational attraction force is felt by the other object. An object of mass m is placed at the point A. The space around an object in which its gravitational attraction is felt by another object, and this region, assume now this is the region, and this region is called gravitational field. Any other object is placed inside the gravitational field at B point. If we placed an object at B point inside the gravitational field, the attraction force act between the object A and B. But outside the gravitational field, if we placed an object at C point outside the gravitational field, there is no attraction force between the object and C. Inside the gravitational field, there is an gravitational attraction force act between two objects, but outside the gravitational field, there is no gravitational attraction force between two objects. Now we discuss about gravitational field intensity. What is gravitational field intensity? Now we discuss about what is gravitational field intensity. An object is placed at the point A. The gravitational field of the object A is extended up to infinite distance. Normally gravitational field of any object is extend from object to infinite distance. Assume now the gravitational field of the object is the region. This is the region of the gravitational field of the object A. Assume now this region is extended up to infinite distance. An object of mass small m is at infinite distance. At this point, the gravitational attraction force will be 0. F will be 0. Now if you bring this object from infinite distance to a point inside the gravitational field at point B, now the attraction force between two objects is F. Now the attraction force between two objects, A is the large object and at B point the object is small. The attraction force between two objects is F. So for m kg mass, the attraction force will be F, but 1 kg mass, the attraction force is F by m. So F by m means the attraction force on 1 kg object, on 1 kg mass. So this is called the gravitational field intensity. This is called gravitational field intensity. So what is gravitational field intensity? If 1 kg mass, if an object of 1 kg mass is bring from infinite distance to a point inside the gravitational field, the gravitational attraction force act on the object is called gravitational field intensity. Again, I tell this, what is gravitational field intensity. If an object of mass 1 kg is bring from infinite distance to a point inside the gravitational field, the gravitational attraction force on that object, is called gravitational field intensity. So gravitational field intensity is represented by E. So E is equal F by M. This is the equation of gravitational field intensity or gravitational field strength. Now, unit of gravitational field strength is Newton per meter. Newton per meter, cause the unit of force is Newton and the unit Newton per kg. Newton per kg. The unit of force is Newton and the unit of mass is kg. So the unit is Newton per kg. Now we discuss about what is the equation of gravitational field intensity. The gravitational field of the object A is drawn. An object is placed at the point A and the gravitational field is drawn. This is the region of the gravitational field of the object A. An object of mass small m is placed at the infinite distance. Now if we bring this object from infinite distance to a point inside the gravitational field at B point, and the distance from object A is R. R is the distance from the object A. The distance between object A and B is R, and the large object, the mass of large object is capital M. Now the attraction force F is G capital M small m divided by R square. Now gravitational field intensity E equal F by small m, so that F is G capital M small m divided by R square divided by small m. So small m and small m cancel. Now equation of gravitational field intensity E equal G m divided by R square. So this is the equation of gravitational field intensity, where m is the mass of the object in which the gravitational field is created by the object, and R is the distance from the object at which point we calculate the gravitational field intensity. This is the distance, small r is the distance from the object and at which point we calculate the gravitational field intensity, and E is the gravitational field intensity. So this is the equation of gravitational field intensity. Now we discuss about the gravitational field intensity is equal to the gravitational acceleration at the surface of the earth. Look at the picture. This is the earth, and total mass of the earth is located at the center of the earth. An object of mass small m is placed at the surface of the earth, and the distance between the center of the earth and the object is equal to the radius of the earth. Now the gravitational attraction force between earth and object is G capital M small m divided by capital R square. Now the gravitational field strength E is equal F divided by small m. Now F is equal G capital M small m divided by R square divided by small m cancel, so Gm divided by R square, which is equal to the gravitational acceleration at the surface of the earth. So gravitational field strength and gravitational acceleration at the surface of the earth is equal, or at any other point outside the earth's surface at any other point the gravitational field intensity and gravitational acceleration are equal. Now we discuss about what is gravitational potential. What is gravitational potential? This is the region of gravitational field of object A. An object of mass small m is at infinite distance Now if you bring this object from infinite distance to the inside the gravitational field of object A, now if you bring an object of mass small m is bring from infinite distance to a point inside the gravitational field, the amount of work needed to bring this object from infinite distance to the B point, the amount of work needed to bring this object from infinite distance to B point is W. So for m kg mass, work done W. For 1 kg mass, work done W divided by small m. This work done represent the amount of work for 1 kg mass or 1 unit mass. That means if 1 kg mass or 1 unit mass is bring from infinite distance to a point inside the gravitational field, the amount of work, this amount of work is called gravitational potential. So gravitational potential means the amount of work needed to bring 1 unit mass from infinite distance to a point inside the gravitational field is called gravitational potential. So gravitational potential represented by B. So V equal W divided by small m. So this is the gravitational potential, and the unit of gravitational potential is joule per kg, and the unit of gravitational potential is joule per kg. Now we discuss about what is the equation of gravitational potential. An object, a point object is placed at the point O, and the gravitational field of this object is extend up to infinite distance. Assume now this is the infinite distance. This is the infinite distance. Assume now an object of mass 1 kg is kept at infinite distance, Now if we bring this object from infinite distance to a point inside the gravitational field, the amount of work needed to bring 1 kg mass from infinite distance to a point inside the gravitational field is called gravitational potential. So now we calculate the amount of work needed to bring from infinite distance to the gravitational field at point P. How much work is needed to bring 1 kg mass from infinite distance to P point? This amount of work represent the gravitational potential at P point. At first, we calculate the amount of work to bring 1 kg mass from infinite distance to P point. Let us consider the amount of work needed to bring 1 kg mass from infinite distance to P point is W. Here, look at the figure. When 1 kg mass is bring from infinite distance to the gravitational field, there is a gravitational force, attraction force act on 1 kg mass, and these gravitational attraction force will be increases when the objects closer to the point O. When the object gets closer to the point O, there is a gravitational attraction force will be increases. That means in this case a variable force acts on 1 kg mass. When 1 kg mass at infinite distance, the gravitational attraction force will be 0, and 1 kg mass is bring from infinite distance to the gravitational field and closer to the object O, the gravitational attraction force will be increases. That means force is the variable force. For variable force, we calculate the work done for small displacement. For small displacement, dr is the small displacement. Let us consider q is the another point, and q to p is the small displacement. dr is the small displacement, and the distance from O to P is r, and the distance between PQ is too much small, and consider the distance between Q to P is dr, that is the distance is too much small. Now at P point, the gravitational attraction force on 1 kg mass, if 1 kg mass is put on P point, and the mass of this object is capital M, so the attraction force between this object and 1 kg mass is G capital M into 1 divided by R square, so that Gm divided by R square. This is the gravitational attraction force on 1 kg mass due to this object. Now if the distance between PQ is too much small, then the gravitational attraction force at P point and Q point on 1 kg mass is nearly equal. If you bring 1 kg mass from Q to P, the attraction force nearly equal cause the distance between PQ is too much small. So at Q point, the gravitational attraction force F equal Gm by R square. At P point, the gravitational attraction force Gm by R square, cause PQ are closer to each other. So for this reason, the gravitational attraction force is nearly equal. So when the object of 1 kg mass is bring from Q to B, in this case displacement occurred from Q to P, and the attraction force and the attraction force will be act from Q to P. So force and displacement are same direction. So work done dW, work done, small work done dW equal FdR. So FdR, F is equal Gm by R square into dr. Now total work done, now we calculate the total work done from infinite distance to P point. At infinite distance work done 0 and small r equal infinite. At P point work done W equal W and the distance r is equal r. So the limit is r equal infinite, then what done W equals 0, and when r is equal r, then what done W equal W. Then we integrate this equation. When r is equal infinite distance, then what done W equals 0, and small r equal small r, then what done W equal W. Now integrating this equation using this limit, integrating this equation, then we calculate the total work done from infinite distance to P point. Now integrating this equation from infinite distance to small r. So integration dw equal w, upper limit 0 and upper limit w and lower limit 0, and capital G capital M is constant, and taking outside the integration Gm. Now at 1 by r square, that means r to the power minus 2 dr, limit is small r equal infinite to small r equal r. So what done W equal Gm integration r to the power minus 2 dr. The integration is r to the power minus 2 plus 1 divided by minus 2 plus 1, and the limit is r equal infinite to r equal small r equal r. Now this is the minus 2 plus 1, this minus sign taking outside the third bracket, minus Gm minus 2 plus 1, that means minus 1, this minus sign taking outside the third bracket, and r to the power minus 2 plus 1, that means r to the power minus 1. So r to the power minus 1 means 1 by r. R to the power minus 1 means 1 by r. So small r equal infinite to small r equal r. Now put the limit. At first putting the limit, higher limit, then lower limit. So minus Gm into 1 by r, smaller is replaced by smaller, 1 by r, minus smaller is replaced by infinite, 1 by infinite means 0, that means 0. Now equation is minus Gm divided by r. This is the equation of gravitational potential. This is the equation of gravitational potential. Here minus sign represent the gravitational potential is negative, because here the work done is by attraction force, that means work done is by the force. If work done is happened by the force, that means potential is negative, gravitational potential is negative, because in this case the work done is happened by the gravitational attraction force. When work is done by the force, that gravitational potential is negative. When work is done against the force, that means gravitational potential is positive. So in this case gravitational potential is negative, because the work is done by the force. For this reason gravitational potential is negative. Now we discuss about the gravitational field intensity and gravitational potential inside a solid sphere. inside a solid sphere at any one point. Assume now this is the solid sphere of radius. The radius of solid sphere is a. Any one point P, gravitational field intensity and gravitational potential. What is the value of gravitational field intensity and gravitational potential at P point inside the solid sphere? The distance from the center to P is r, and the radius of the solid sphere is a. In which formula we use to calculate the gravitational field intensity at P point? At P point, E is equal gm minus gm divided by a cube into small r. By using this formula, we calculate the gravitational field intensity at P point for solid sphere inside the at any point inside the solid sphere. We calculate the gravitational field intensity at any point by using this formula. Similarly, we calculate the gravitational potential at P point is minus gm 3s square minus r square divided by 2a cube. By using this formula, we calculate the gravitational potential at P point inside a solid sphere. Outside the solid sphere, this is the solid sphere of radius a. Outside the solid sphere at any point P, how we calculate the gravitational field intensity and gravitational potential? The distance from center to P point is r. So electric field in gravitational field intensity E is equal gm by r square. By using this formula, we calculate the gravitational field intensity at P point. Similarly, we calculate the gravitational potential. B is equal minus gm by r. By using this formula, we calculate the gravitational potential at P point. By using this formula, we calculate the gravitational potential for solid sphere. For a solid sphere outside at any point, we will calculate the gravitational potential by using this formula, and gravitational field intensity by using this one. For a hollow sphere, inside a hollow sphere at any point P, O is the center and P is the point at which point we calculate the gravitational field intensity and gravitational potential for hollow sphere. The formula is EP equal gm divided by r square. R is the distance from O to P. R is the distance and the radius is a. Radius of the hollow sphere is a, and the P point, the distance from center to P point is small r. So the formula is EP equal G capital M divided by R small r square, and the gravitational potential BP is equal minus Gm by R. By using these two formula, we calculate the gravitational field intensity and gravitational potential at any point inside the hollow sphere. At any point outside the hollow sphere, at any point P is the point outside the hollow sphere, and the distance from center to P point is r, and the radius is a. Now the gravitational Now the gravitational potential is gravitational field intensity, and the gravitational potential is these formula we use to calculate the gravitational field intensity outside the holosphere, and this formula we use to calculate the gravitational potential outside the holosphere. Sorry, mistakenly I told these inside the holosphere, but it's not inside the holosphere. These two formula we use to calculate the gravitational potential and gravitational field intensity outside the holosphere. Okay, thanks to everyone.